class is in, so let's head to Alexis. Hey Jen, good morning. Okay, I showed you we've all got these balloons in class this morning. I am at Munson Elementary School, and some of them are sticking to our students' heads. And the reason for that is we were demonstrating static electricity, we were explaining electromagnetic charges, and we were learning about lightning. So the reason, everybody grab your balloon, if you rub it to your head, my hair might be sticking completely up at this point. If you rub it to your head, the balloon will either stick to your head, or if you pull it away, let's see, I have a lot of hairspray and it might not work, but if you pull it away, the balloon takes your hair with it. We're all gonna have some messy hair after this. And I explained to the students that it's kind of the same when it comes to what we see as lightning. It's just a really big electromagnetic spark. So do you remember what the reason for the balloon sticking to your head is?
Static electricity.
Static electricity. So another way that you can demonstrate this, which we did here in the classroom, but you need a lot of energy for, and we just didn't have enough time, is you can take a pair of wool socks, which I've got here. You also take a styrofoam plate and a piece of tin foil, a tin pie tin would work as well, and then we've got a eraser with a thumbtack stuck through it, all right? And when you can tell that there's a little bit of electromagnetic field there because it is picking up the styrofoam plate with absolutely nothing touching it. So what you do is you take the wool socks. You could do this a million different ways, but these are the things that I had laying around the house, and you might have them too. You take the wool socks, the styrofoam plate, oh, it's sticking to me too, and you rub it real hard and firm for about 2 to 10 minutes. The longer that you rub it, the more static electricity will form. So you rub it, and then you take your pin with your pencil and your tin foil and you lay it on top, okay? And what you do is you can take your finger or a fork if you don't want to feel the shock, and the closer you get to it, oh, I did feel it actually. I felt it that time. You can feel a spark, very similar to if you go to grab a handle or if you've been running around the house in your socks on carpet. It's all the same. It's electrons and protons creating an electromagnetic charge. The difference between this and lightning that you see outside is that is just a really big version of it. We also learned today, this was pretty cool. Does anyone remember how we tell how far a thunderstorm is away from you? Anybody want to give me the answer for that?
By counting until you hear the thunder and then dividing it by 5.
That's exactly right. So if you see lightning outside, all right, you start counting however many seconds it is between the lightning and the thunder. Take that number and divide it by 5. That's how many miles away a thunderstorm is. So now that we all have, you know, staticky hair and balloons to play with, that wraps up this week's weather class. Steph, Todd?
Awesome.
Well done.
Yes, another great session.
We knew when we hired you, lightning had struck.